Welcome back to video number 2 on this lovely dreary afternoon. Summary of the law of cosines is in front of you, standard form and the alternative form for solving for angles. Very nice resource page here for you to print and save somewhere if you wish. Okay, so moving on, how do we actually use this in practice? Here we go. The law of sines, which is familiar to us as simply being proportions in triangles between the sides and the sines of the angles, works best if you have more information about angles, if you know two angles and a side. And like I said, we'll talk a little more about this on Monday next week. The law of cosines works best if you have more information about certain sides in certain places in the triangle. So how does this actually work? If you have your old notes, or if you're going to use this particular video to help, this is actually example, I think it's number 2 in the notes we've downloaded from last Monday when we were here last on the 27th of February, 2017. Let's put a date stamp on this guy. So notice in this one we have all 3 sides marked, and we are to solve the triangle. So it is our job to find all of the angles. Notice if we try to start drawing our loops, as I suggested from earlier, to try to match up to see if the law of sines is appropriate to use, we've got a problem. Any 2 of the loops I choose, I only have 2 numbers, and to actually use that, I need 4. So let's back those off and out of there. So I cannot here use the law of sines. Just as a suggestion and a hint, as you're solving for angles, I'm telling you that we do need to use the law of cosines. Go and find the smallest angle first. That seems to work best and eliminates any problems that we would have potentially. There are some problem issues we might want to talk about later on. So I've chosen angle A because it's the smallest angle. I can tell because it's across from the shortest side. So now I simply apply the law of cosines to this particular diagram. So I know I've got the A position here, the B position here, and the C position here. Once again, standard labeling. Put the little letter across from the big letter that are in the opposite corners. So I've got an A of 12, a B of 20, and a C of 14. For this particular slide, we've got angle A now at 36.18. And to find the rest, if you notice now, I have just enough stuff indicated here that I can actually do this and this. And now once I've used the law of cosines once, I can come back and use the law of sines to finish off. And once I find angle C here, whatever it might be, I can find angle B by simply subtracting A plus C to use the triangle sum deal. Okay, that's how these will all work. Next example coming up. A equals 12, B equals 20, C equals 14, and I want to find all of the other angles. So angle A was the one I was going to target first. So if I'm looking for angle A, I want to be using the cos of A, and then once I figure out the decimal value, I can work backwards and figure out the angle. So, as I said, there is kind of a nice way to think about writing this. And when I write this format, and then we'll fill the numbers in, I always remember that the minus a squared piece of this goes here, and then the others by default will be these 2, and underneath will be 2b and c. So now we can place the numbers in place. So if my pen is still on here, no it's not. Cos of A will equal 20 squared plus, 14 squared, almost wrote the 12, minus 12 squared, all over 2 times 20 times 14, those same 2 numbers I wrote first. And then it's time to find your good old calculator. One word of warning, there is a place where students sometimes mess this up when they do the division. You do want to be sure that you do the numerator together, and I would suggest that you figure out the number for the denominator first. Here's why. If you type this in a calculator, you're typing 20 squared plus 14 squared minus 12 squared, no problem. Then you hit divide and type the 2 and then the 20, however you do that, it will divide your numerator by 2 and then multiply that by 20 and by 14. Technically, you're really dividing by 20 and you're dividing by 14. So that's something to watch out for. So I've done this on the calculator, and I have done it both ways. If you do it the wrong way that I just mentioned, you will come up with a number that looks something like this. Does that look really awful to you? It should. We know the cosines have to be somewhere between 0 and 1. If you've done it correctly, this is something like the number you do end up with. So what I actually did on my calculator, I went back and I put parentheses around the top, hit my division sign, and I put parentheses around the bottom. And that's a sure way to make sure that things are going well for you. Last step, of course, we are looking for angle A. So I go second cos, again not second sine, and I will pull the entire answer back in and get an answer of A equals 36.18. I will keep 2 places for accuracy's sake. And I have solved for a single angle. So looking back, and here is example number 2. Hopefully that the last ordering of business there wasn't too confusing for you. I think the slides got mixed up a little bit. Anywho, notice here we have, let's actually do a double check. Do we have the ability here to do law of sines? Looks like nope. Once again, we're out of luck. We have nothing in 2 spaces. So we do have information on a side 8 and a 7 and the angle between them. So in a sense, this kind of looks like we have numbers in this kind of position. It's side angle, side labeling. And that's an indicator that we should use law of cosines. And the side we will be solving for first is letter B. It is always the one across from the angle, which makes this kind of easy to set up. Once we get this, of course, you might notice that we will have 2 numbers here and that we actually can bring in and use the law of sines. Now looking at the angle, this is a case where we'll be solving for b squared. So if you remember what that looked like, b squared equals a squared plus c squared minus 2 times something, and those 2 somethings were the same 2 letters we just squared, and then times the cos of the angle we're looking for, and that angle matches the b squared which is there. And we can actually now start to fill in our numbers. So let me jump to our next slide and continue. Okay, so we're solving for b squared, and we had an 8 squared plus a 7 squared minus 2 times 8 times 7 times the cos of 125.2 degrees. Now these are all numbers, so we can go find them. Yeah, we know that's 64 plus 49. And the trick here is to get this number as a single number. Notice there are all multiplies in between everything we have here. And multiplication, of course, takes priority over subtraction. We have to get this number first. Let me add together 64 plus 49. And now I'm going to go 2 times 8 times 7 times cos 125.2. And this number is a negative 64.56 and a bunch of other decimals. Since it's minus a negative, I'm going to end up adding these 2 numbers together, actually, aren't I? So I'm going to keep my number in my calculator. I'm going to type in negative and pull my answer back in so I can turn him positive and add him to 113 in this case, and I get about 177.56. I will keep that number, and I will square root and pull the answer back in, and I get a b value of 13.32517999, just to show you all the digits. There's my decimal point. Now, if you wish to, you can take this number, and your calculator has a store key that looks like this. And if you type that key now, it will take your answer and put it into, and if you wish, You can now type the green alphabet key. And let's see, the key that has the B above it is the key that has apps in purple. And what that will do is it will store this entire value, decimals and all, even the ones it doesn't show you, to the letter B. So if you want to use this number again, in place of it, you simply type in alpha apps to get the B value out. This is kind of a handy shortcut to use for any values at all you'd ever calculate where you want to keep a lot of the decimal places so you can be accurate. Store them to letter values. The store key, by the way, that I'm talking about is right above the on key on the TI-84 family of calculators. Once we get that, then for the next piece, again, we employ the law of sines, draw your loops, set up your proportions, and solve for the remaining values.